All right, so these are your electron configuration notes. So we have different orbitals, and they're across the sections of the periodic table. They're very important in understanding how we do electron configuration. So they are the S, P, D, and F block on the periodic table. There are special rules for the D and the F blocks, and we'll kind of get to that later in the PowerPoint. The D block has N-1 and the F block has N-2. And again, we'll touch on that again later in the PowerPoint. So right now I want you to take a moment and on your blank periodic tables, I want you to outline the different parts or the different blocks of the periodic table. So here in red, you can see that there's S. So whatever color you pick, just outline this part in whatever color. And remember, you're only outlining. And then if you'll create a legend, like up here where it says S block, you don't need to write the big S right here. Also, just to note, helium, although it's all the way over here, is a part of the S block, so make sure you outline this one block in the same color as you outline the whole thing over here. Next, we have our D block, and so these are our transition metals right here. It's 10 across, so outline these in a different color. All right, and again, add it to your legend. Then we have the P block right here for the p orbitals. It's 6 across, and you'll want to outline all of these in the same color and add them to your legend. And last, we have the F block here. It's 14 across, and you'll outline those in their own color and then add them to your legend. So if you need to pause the video right now to do that, go ahead and pause it. All right. So what do the S, the P, D, and F mean? So these refer to the sublevels within the principal quantum level, or N. So that's going back to the N. So for N equals 1, there's only one sublevel, S. For N equals 2, there are two sublevels, S and P. For N equals 3, there are three sublevels, S, P, and D. So within each level, there are a different number of sublevels. All right, so these are different orbitals. And where we get the N number, so how we know what the N even is, where does that come from? So if we look on our periodic table, over on the side where it says period and it has 1 through 7, this 1 through 7 is actually the N. All right. So if I'm talking about N equals 1, I'm talking about hydrogen and helium, because those are the only two things where there's on the one row. And you'll notice that hydrogen and helium are both S blocks. So when it talked about for S or for N equals 1, that there are only S orbitals, that's what that means. For N equals 2, see I've come down here. I have my S orbital here. It has my two things in it. But if I go across where I'm still in level 2, I also have p orbitals. You see that? All right, next I'm coming down to N equals 3. It looks like I only have S and p orbitals. All right, but if I come down to level 4, I get S, and then I'm in the D. And so this is what it means when it says D is N-1. So this is actually level 4, right? Because I'm across from the 4 right here. So this would be level 4, but since it's a D, it's always N-1, so 4 minus 1. So this row actually is 3D. All right, we have 4S, and then 3D, and then we go back to 4P. All right, and it's the same way down here. If I have 5S, it would be 5 minus 1 here, so 4. So 5S, 4D, 5P. All right, and where we get to the F, so you'll notice these two series actually come right here, lanthanide and actinide, so those are right here. And so this lines up with the 6, n equals 6, because it's right here, but it's n minus 2, so it would be 4, so it's 4F and 5F. All right, so that's what those N numbers mean. They're just talking about the energy levels within the different kinds of orbitals. All right, so this is what electron configuration looks like. So I kind of went over this and how we got each of these things in the previous slide, but it kind of really shows it in terms of how we talk about electron configuration. So all electron configuration is showing the different electrons and what orbitals that they correspond to as they're written out by energy level. Okay, so we write it as we read it. So what that means is I'm going to start in the top left, all right, and if I'm trying to write the electron configuration for whatever this element is right here, right, this is where I'm going to end. So I'm always going to start in the top left, and I'm going to read across, and then I'm going to come down and read across just like you would a book, right? You go left to right, bottom to top, until eventually I get to whatever element I was originally trying to get to. All right, so here's an example, arsenic. So if you look at arsenic on the periodic table, you'll notice that its final spot is 4p3. So what these little numbers mean up here is just how many times it's moved over within that block. All right, so I'm going to go back. So if I go to 4p3, it'd be 4p is this one, so I'd go 4p, 1, 2, 3. This is where arsenic is on the periodic table. All right, so all of the things that led up to that, I did 1s, so I went 1s, and I covered 2, so that was the 2 number. 2s, I went across, so I covered both of those, so 2s2. Then I went 2p, and I covered all 6 of those, 1, 2, 3, 4, 5, 6, so that's where I got 2p6. Kept going, had 3s2, because I covered both of those. Then 3p6, because I covered all of these, right? As I'm reading across, I read through all of those. Down to 4s2, and then remember I went 3d10, because I went across all 10 of them. And then I got 4p3, because arsenic would be right here. So I stopped here. I didn't go all the way and do 6, right? Because I stopped wherever I stopped reading. So if I go back, so this is my electron configuration. So if someone is asking you, and by someone I mean me, to write an electron configuration, this is what your answer will look like, okay? It's the orbitals and then the different electrons that they covered across it. So the first number, the 1, is the row it's in, or the principal quantum number or energy level. So that's kind of what I went over just a minute ago. The character, which is the letter, is the block it's in, which it refers to its sublevel. All right, then the superscript, so this exponent right here, is the total number of electrons in the sublevel, right? So I went all the way through the 1s sublevel, so there were 2 electrons in that, because I went across 2 elements. Same thing with 2s, 2p. All these are the electrons that are added each time you move across the periodic table. So there are some special rules for D4 and D9. So sometimes an electron configuration will end with a 4 or a 9 electrons in the D sublevel. So this is only for the D sublevel. It does not refer to any S, P, or F, only D. So if it ends with D4 or D9, these are actually unstable. And so they will actually steal electrons from the S sublevel to make it more stable. All right, so if I look at chromium on the periodic table, what I would normally write is I would do my electron configuration, go 4s2 and 3d4. But since I have the d4, I know that this is very, very unstable. and we'll get into why kind of later. And so what actually ends up happening is I get 4s1 3d5. So this d orbital actually stole one electron from the 4s right next to it, making it 4s1 so that it could be more stable as 3d5. All right, so the same thing would go for if you had a d9, right? So if I'm talking about silver, it ends with 4d9. And so it would steal one electron from this 5s orbital, making it 5s1 4d10 to make it more stable, right? Silver looks nice. We want it to be stable. The noble gas configuration is the shortcut way to do this. So it's convenient and it's nice. So I will ask you to do the longhand just kind of until we get the hang of it. And if I want you to do the noble gas shortcut, I will ask specifically for that. So what it is the noble gases are all the way on the far right side of the periodic table. So it's everything under helium. So helium, neon, argon, krypton, xenon, and radon. So each noble gas finishes a row. So they're all the way to the right. They finish that energy level, whatever that 1 through 7 number is. So the noble gas configurations take advantage of this by kind of creating a shortcut to what you have to write. All right, so if I look at helium, right, it has a 1s2 configuration. If I'm looking at carbon, carbon includes 1s2, right, because it's something after helium. So the noble gas configuration is basically carbon is on the energy level 2. So I go up to whatever noble gas is above that energy level. So it'd be helium because it's at the 1. And so I would write helium in brackets. So you have to put it in brackets or I won't know what you're talking about. And then I write everything that comes after that noble gas. Okay, so right here it's not saving you a lot of time. However, if I'm looking at arsenic, where I go all the way to 4p3, right? If I look at whatever my 3p6 is, because that's whatever my noble gas is on the periodic table, argon would be that noble gas. So my noble gas configuration for arsenic will start with argon in brackets. And what that is saying is that, okay, I'm not going to write all this. So instead I'm going to write argon so that I don't have to write all of this right here. But we're just going to assume you know that I'm talking about the electron configuration for argon, which is this. And then everything that comes after that, or the row that's below it. Okay? It cuts down on a lot of writing, and we like that because that's a good thing. Okay, so that's where we're going to stop today. Make sure you have all of this in your notes, and I will be doing a note check later.